Assalamualaikum warahmatullahi wabarakatuh. Hello guys, welcome to subtopic 2.3. So in this subtopic, we're gonna learn about four items. The first one is a vector and scalar quantity. The second one is a vector addition and subtraction. Next, we're gonna learn about graphical representation, and the last one, vector resolution. There are two topic learning outcomes for the subtopic. The first one, at the end of this subtopic, you should be able to compute the vectors problem using graphical and trigonometric method. The second one, you are able to manipulate the vector concept in solving the dynamics problems. What is scalar quantity? A scalar quantity is a physical quantity which has magnitude but no direction. As an example, distance, speed, length, volume, time, mass, and density. All the examples just have the magnitude but no direction. Vector quantity. A vector is a physical quantity which has both magnitude and direction. Example, displacement, velocity, acceleration, force, and momentum. This slide shows differentiation between scalar and vector quantity. Remember, if it's just a number, it is scalar quantity. But if it has a number and direction, it's a vector. Imagine you are delivering a parcel. The destination matters, right? That's how direction matters in vectors. Vectors are represented by arrows. The line shows the magnitude and the arrow points to the direction. Remember, vectors are not just numbers. They have both magnitude and direction. So when we add or subtract vectors, we are dealing with arrow that point somewhere, not just plain values. Let's look at the simplest case of vector addition when both vector point in the same direction along a straight line. Imagine you are applying two forces, both pushing to the east. One force is 300 Newton and the other is 300 Newtons. Since they point in the same direction, we just add their magnitudes. 300 Newton plus 300 Newtons is equal to 600 Newtons to the east. The length shows the magnitude. So that's why line for total vector addition, which is 600 Newton, will be longer because the length of the line is influenced by the magnitude of the vector. Easy, right? Now let's talk about vector subtraction. To subtract a vector like 300, subtract with 200 Newton, we reverse the direction of vector 200 Newton and then add it to 300 Newton. This is called adding the negative of a vector. So the answer will be 100 Newton and the line will go to the east. There are two methods in solving vector resolution problem. The first one using graphical method and the second one using trigonometry method. Vector resolution using graphical method. So what is graphical method of vector addition? It involves visually representing vectors on a diagram and combining them using those methods to find the resultant force. The methods are head-to-tail method and parallelogram method. Parallelogram law in vectors. The parallelogram law of vector addition is used to determine the resultant of two vectors acting a point. This slide shows on how to draw parallelogram method. What is parallelogram? Parallelogram is a quadrilateral four-sided polygon with opposite sides that are parallel and equal in length. Solve vector resolution problems by using trigonometry method. Resolve vectors into components using trigonometric function, cosine and sine, or the Pythagorean theorem. There are 5 steps in solving vector resolution problems. The first one, draw free body diagram. The second one, resolve forces into x and y components. The third one, total force along x and y axis. Fourth, calculate resultant force and its direction. And the last one, draw the complete diagram that consists of magnitude of resultant force and the angle of the direction. Pythagorean theorem is used to calculate magnitude of resultant vector. As an example, if we are given two components of vectors, one in the horizontal direction and another one in the vertical direction, in order to find the magnitude of resultant vector, we can imagine these two components at the sides of a right triangle. The vector we are looking for, which is the resultant, is the diagonal or the hypotenuse of that triangle. We are using sine and cosine functions from trigonometry in solving a single vector into two perpendicular components, one along the horizontal and another one along the vertical. Every time we solve a vector problem, first and foremost is to draw a free body diagram or FBD. FBD is a simple sketch that shows all the forces acting on an object. It helps us to visualize the situation and plan how to solve the problem. Let's say you have a force of 50 Newton acting at an angle of 30 degrees above the horizontal. We have to break it into horizontal x and vertical y components. Using trigonometric functions, the horizontal component of the force Fx is found using cosine, which is Fx is equal to F multiplied with cos theta. And the vertical component Fy is found using sine. Fy is equal to F multiplied with sine theta. But what if we have more than one force? Let's resolve each vector into x and y components separately and then add them to find the total force in each direction. Add the x components together, then add the y components. We now have the total horizontal force and the total vertical forces. After we calculate the total force along the x and y axis, we can use them to find the resultant force. Remember, the resultant force Fr is the vector sum of all the individual forces. We treat the x and y components as the sides of a right-angled triangle and use the Pythagorean theorem to calculate the resultant. Fr is equal to square root of total Fx squared plus with total Fy squared. Next, we calculate the direction or angle of the resultant force relative to the x-axis using the tangent function. Theta is equal to inverse tangent of total Fy divided by total Fx. Last but not least is draw complete diagram. Complete diagram is a vector diagram that describes total force at x-axis, total force at y-axis, resultant force, and the direction of resultant force. We have just learned how to resolve a vector into horizontal and vertical components using cosine and sine, add the components to get total force along the x and y axis, and use those totals to calculate the resultant force and its direction. I hope this explanation helps you to understand the process better. Now, let's try one example together, step by step, so you can apply what you have just learned before. Thank you.